Yes, good evening, everyone. My name is Maria Elaine Lau, and today I am going to discuss about the photoelectric effect. Okay, we all know that light has dual nature. So, yung phenomena of interference and diffraction and etc. So, it can be explained on the basis yung wave theory of light. So, we do have also a photoelectric effect. Ito naman difference from wave theory of light because a photoelectric effect is a basis of particle theory of light. So I'm gonna give you some history about photoelectric effects. So we do have here in 1839, Alexander Edmond Becquerel, if I'm not mistaken the pronunciation, so observed the photoelectric effect via an electrode in a conductive solution exposed to light. So si Alexander, siya yung nag-discover ng photovoltaic or photovoltaic effect while studying the effect of light or electrolytic cells. So, yung pinag-aralan niya about photovoltaic, so ito yung mga electrons he discovered that the conversion of lights into electricity using semiconductive materials. So yung makikita natin to ngayon usually sa mga solar panel. So we do have here Heinrich Hertz observed the photoelectric effect in 1887 na and the production and reception of electromagnetic waves. So we have also Philip Edward Anton von Leonard observed the variation in electron energy with light frequency. Also Albert Einstein's mathematical description in 1905 of how the photoelectric effect was caused by absorption of quanta of light. So nagkaroon ng battle na tinatawag na kung saan is nagkaroon ng contradict and collaboration si Einstein and Leonard when it comes to photoelectric effect. So I'm gonna show you the video here. Okay. Okay, now we are done about the video that okay, it's about the Einstein and Leonard battle. So consider that the photoelectric, I mean the light, one of them insisted that the light is made of waves and the other one is made of particles. But Einstein concluded or give us some conducted a hypothesis and also a formula to formulate that the light is can be a wave, particles, or both. Okay, photon, quantum of light. So in 1905, Einstein proposed that electromagnetic radiation of light is made up of photons. Thus, the photon is the elementary elements of light or lights it made up of photons. So Einstein showed that light energy is not emitted continuously, but it is emitted by individual amount of energy called as quantum of energy. So if you can see the pictures here, so it means the when the light radiates on a photosurface, so nagkakaroon ng emission or nagkakaroon ng release of electrons. So before that, let us differentiate again what is light wave or what is light when it comes to wave or particles. So during before the we consider the light is made of particles, so the evidence supporting wave nature of light, ito yon, we already familiar about these words: reflection, refraction, diffraction, interference, and also polarization that can be observed. Okay, we have also sa evidence supporting particle nature of lights. So, ito na yung ano, during 1900, so yung atomic spectra, uh, enable for us to characterize color pattern and black body radiation, and ito yung absorption and emission of energy. So, but now I am going to discuss more about photoelectric effect, which is photoemission of electrons. So the question here is, what is photoelectric effect? So before we are going to define the definition of photoelectric effect, let us go back about what we call electromagnetic spectrum, because it has something to do, or we are going to differentiate later on what is the connection of this intensity and frequency or increasing of energy enable for us to really identify what is photoelectric effect or bakit siya nangyayari. Okay, so as you can see, we do have here gamma rays, X-ray, ultraviolet, and we have also this the small part sa middle. Ito yung visible light na kung saan is nakikita natin. So we do have here infrared and radio waves. So as you notice, as you have noticed, when the waves is longer, it means the frequency or the wavelength is lower. But when the waves is shorter, it means the frequency of the waves is higher. And then later on, we also be able to identify yung mga color kung bakit siya malaking factor kung bakit nagkakaroon ng photoelectric effect. So, okay, the definition of photoelectric effect. So, the photoelectric effect refers to the emission or ejection of electrons from the surface of or generally a metal in response to incident light. So, when you see photoelectrons, so we do have here this one, the arrow. Look at this. So, this is the wave. So, dahil shorter wave, it means higher frequency. Okay? Then this is what we call the photosurface, and then nag-emit or nag-release siya ng electrons, So, kaya nagkakaroon ng tinatawag na photoelectric effect. So, photoelectric effect, in the photoelectric effect, electrons are emitted from matter. Ito yung mga metals or non-metallic as a consequence of their absorption of energy from electromagnetic radiation or very short wavelength and high frequency. And also nakalagay na i-indicate dyan is yung radiation. So when we say photoelectric effect, ito yung mga electric charge particles na kung saan is nagre-release from a photosurface or yung tinatawag natin na metal or within a metal when it absorb electromagnetic radiation effects. So nagkaroon ng ganon is nagkakaroon ng ejection of electrons from a metal plate when light falls on it. This is the light photons, this is the photosurface, and this is electrons. Electrons ejected from the surface. So we have here a photoelectric effect. So we do have photoemissive, a material that can exhibit the photoelectric effect. We also call this as a photosurface. So photoelectrons, ejected electrons. Ito yun yung kanina, yung na-release na siya. So, okay, let us differentiate first what is classical physics from quantum physics. Okay, so we do have your classical. When we say classical, yung light is we consider or made of wave. Well, quantum mechanics, the light as a particle. So, we have here whether electrons are ejected depends on, so pag classical physics siya, intensity. So, pero pag quantum, frequency. So, second one, the kinetic energy of ejected electrons depends on intensity pa rin ng lights when it comes to classical physics. Well, the quantum mechanics, it also depends, not also again, from the first one is frequency pa din. And yung the third one, sa classical daw is fixed time. Well, the quantum mechanics, nangyayari daw ito with a certain frequency. Kaya we can prove that the proves duality of light. So, photoelectric effect, classical versus quantum mechanics. So, this observation supports light being a particle rather than a wave. So, kung sa before na sinasabi nila na is light is a wave, sa photoelectric effect is particle na siya. So it requires that electromagnetic energy be quantized as Max Planck's proposed earlier, yung explanation niya of black body radiation. So parang nag-collaborate sila dito ni Albert Einstein. So nag-extend siya sa Planck quantitation energy dito stream or of photons. So dito na yung sinasabi natin na kung saan is ang photoelectron daw is when you see photoelectric effect, it has something to do with light and electron. So, it also proves that light acts as a particle, di ba, sabi. So, kasi yung light kasi, di ba, discrete packets of energy siya na tinatawag natin na photons. So, si Max at si Einstein, nag-collaborate sila ng inadapt pala ni Albert Einstein itong constant Planck formula niya na equivalent ni Planck sa energy na kung saan equivalent to 6.63 times 10 raised to 34 joules per seconds para ma-measure natin yung energy of photons. So, i-multiply mo lang siya sa frequency. So, actually, it's more on computation, pero hindi ko siya masyadong inelaborate dito. Pero merong formula na kung saan is pwede nating ma-measure kung may photoelectric effect pang nangyayari or ilang amount pa ang meron doon. So we do have here work function, so threshold frequency. The frequency of incident radiations or yung photons below which there is no ejection of electrons from a metal. So ito yung symbol niya in what? Unit. So, ito pa another one. So, ibig sabihin, ang threshold frequency ito yung minimum frequency of incident radiation below which is the photoelectric effect emission is not possible completely. So, ibig sabihin, hindi lahat ng light na pwedeng i-radiate natin sa isang metal is hindi magre-release ng electron. So, ibig sabihin, work function niya, ibig sabihin, the minimum amount of energy required for an electron to escape from a metal. The value of the work function depends only on the metal. So, ibig sabihin, hindi lahat ng niradiates or tinapon na lights doon sa isang metal or sa isang photosurface, kung hindi siya enough amount para makapag-release ng electrons, hindi talaga siya mangyayari. So, we have here work function of selected metals. So, ito yung mga metals na kung saan is pwedeng mangyari ang photoelectric effect. So, we do have sodium. Itong sodium na to ay usually is ito yung mga silver na makikintabs. And we do have also aluminum, copper, zinc, gold, platinum, plumbum, and iron. So we have also here loss of photoelectric effect. So photoelectric effect is directly proportional to intensity. So if the frequency of the incident light is less than the threshold frequency, then no electron ejected, no matter what the intensity. So ibig sabihin, katulad nga na sinabi ko kanina, kung less than ang amount ng frequency na in-apply natin doon or matatanggap ng photosurface, hindi siya magkakaroon ng magre-release ng electron. So, the maximum kinetic energy of the electrons depend on the frequency of the incident line. So, katulad nga ng dinifferentiate natin kanina, kung enable for us to consider or to identify or to if it is a particle or wave, di ba? Ibig sabihin is what? Kung kanina sa wave, para malaman natin ang wave, saan siya, is because of intensity. While sa particle, so ang importante doon is yung kanyang frequency para magkaroon ng release of electrons. So the electrons were emitted immediately, no time lag. So we have here Einstein's equation. This Einstein's equation to measure what amount or how much or what amount or how much photoelectric effect ang meron doon or nangyari doon. So ayun yung formula. We have here maximum kinetic energy in energy of photons, work function of metal. So, this one is we do have photoelectric effect. So, ito na yung experiment na ginawa nila. The given experiment is, is used to study the photoelectric effect. Ito yung tinatawag natin evacuated glass tube. So, itong evacuated glass tube na to, may two zinc plates dito. Ito yon. Okay? Yung plates na yan, are naka-close siya. Okay? Sila yung nag-a-act ng what? Nag-a-act ng act as anode and photosensitively. So, ibig sabihin may negative and positive dyan. So, itong two plates na to, magkakonect ito saan? Sa ammeter. So, itong ammeter na to, ammeter na to, ito yung kung paano masusukat kung gaano kadaming current flows doon sa meron sa circuit para malaman natin kung ilang electrons are ejected out of the plate. So halimbawa si light. Si light is nag-radiate dito sa plate na to. Siyempre kung katulad ng sinabi natin, kung may enough na light na frequency na meron tayo dito, ibig sabihin magre-release siya ng electrons. So, pag ito tumama dito, mag-aano siya dito, mag-eject siya dito out of the plate. So, magkakaroon ng current flows doon sa secret. And then doon is malalaman natin kung ano yung photocurrent na meron doon. Okay? para malaman natin. Actually, meron siyang video na napanood ko na meron siyang na kung saan is na-experiment siya. Pero ano siya, parang apps, pero hindi ko siya mahanap actually eh. So, meron doon na parang saturation, what kind of light or color of light na kung saan is merong effect, what kind of light para magkaroon ng emission or makapag-release ng electrons para makonsider natin ito na may nangyayari ng photoelectric effect. So, wave theory prediction. So, if light is wave theory prediction, ito yon. Kung wave daw siya, if the light's intensity increase, the number of electrons ejected and their maximum kinetic energy increase. Because the higher intensity means a greater electric field amplitude, and the greater electric field should eject electrons with higher speed. So, the frequency of light not affected the kinetic energy of ejected electrons. Dito sa wave theory prediction. Well naman sa photon, so if the light is particles, ito daw yon. So pag in-increase daw natin yung intensity, increases number of electrons but not the energy. So above a minimum energy required to break atomic bomb, kinetic energy will increase line early with frequency. There is a cut-off frequency below which no electrons will be emitted regardless of intensity. So yun yung inaano natin ha. Pagka particles is it's not something to do with the intensity but the what frequency. So ito, the photoelectric effect does not occur when the red light strikes the metallic surface because the frequency of red light is lower than the threshold frequency of the metal. So ito yung sinasabi ko kanina. Ano yun? Yung mga visible color na kung saan is makikita natin na sinasabi ko yung kanina sa electromagnetic spectrum. Diba? So parang kung i-consider mo, mas higher, mas lower wave si red. Okay? So, it means pagka longer wave, it means lower what? Frequency. Pero pagka naman katulad nito, to lower to sa red. Pero pansinin nyo, pagka medyo may wave na siya, medyo shorter, nagre-release pa rin naman siya ng electron, but konti lang. Pero pagka shorter wave ng ginamit natin, so ito si si purple ba to or si blue. So ibig sabihin mas higher yung frequency niya, ibig sabihin mas malaki ang tendency na mas mataas ang electron na kanyang mare-release. So let's read this. The photoelectric effect does not occur when the red light strikes the metallic surface because the frequency of red light is lower than the threshold frequency of the metal. So, kailangan natin tandaan na si red is nasa lower frequency siya. Kaya, nakalagay does not occur. Okay? Hindi doon nagkakaroon ng photoelectric effect. So, second one, the photoelectric effect occurs when green light strike the metallic surface and photoelectrons are emitted. Ibig sabihin may nangyari. Nag-release siya ng electrons pero konti lang. Okay? The photoelectric effect also occurs when blue lights strike the metallic surface. However, the kinetic energies of the emitted photoelectrons are much higher for blue light than for the green light. Ito nga yung sinasabi ko, mas mataas daw. This is because blue light has the greater frequency than green light. So yun yung sinasabi ko kanina. Parang sa rainbow. Yung spectrum, so yun. And then, okay, a photoelectric effect explained. So, para mas maliwanawan natin, ano ba yung parang pinakasimple na pwede nating malaman kung paano ba natin na-explain or matatandaan si photoelectric effect. Okay, so light is going to hit the metal. If the frequency of the light is above the threshold frequency, then nagkakaroon daw ng band electron will be emitted. So, nag-release from the metal. Okay. Parang siya, paano mo ma-relate? Halimbawa, think about hitting a ball into outer surface. Halimbawa lang, kunyari, ako si light. Okay, ako si light. Then, si bola is tinapon ko. Hinagis ko. Para makapunta doon, halimbawa, hinagis ko sa mataas na kisame, kaya lang yung energy or yung bilis na nirelease ko or in-apply ko doon or niradiate ko doon is hindi ganun ka taas. Ibig sabihin is below the threshold frequency siya. So, ang mangyayari, ano mangyayari? Walang mangyayaring photoelectric effect. Okay? Pero, sabi, pero pagka if yun na, pagka if you don't hit it hard enough, babalik lang siya sa'yo. Kahit, kahit ano, ilang beses mo pa to gawin. Parang ganun din yan, okay? Pero, halimbawa, kung sa outer space lang pala yun, ba, i-consider natin as outer space. Kung tayo, tao, ibato natin yung bola, hindi siya makakaabot sa outer space kasi wala tayong enough energy kahit gaano karami pa natin ito ihagis. Pero pag halimbawa daw, kung si Superman daw ang naghagis nito, dahil si Superman is superhero, so capable siya, may ability siya na para gawin yon. So possible na pwede siyang mapunta sa outer space. So ganun din yung sinasabi natin na photoelectric effect. Okay? So, ibig sabihin, kung ikukumpara natin or i-relate natin siya dun sa photoelectric effect. So, no matter how many photons strike the metal, if none of them has sufficient energy to eject an electron from a metal atom, you won't get a current. So, hindi mangyayari. So, if the energy that taken up by the electron is sufficient naman daw to allow it to be released from the metal atom, syempre magkakaroon ng current. Okay? Kung may papanoorin kayo na kung ipagbabase nyo dun sa mga color, yung sa rainbow, sa spectrum, merong experiment doon na nakita ko na yung katulad nga sa kulay, na para siyang transparent lang actually siya. Pero yung pagkakaiba ng transparent siya is may kulay-kulay. Kung si red yung ginamit nila, is parang wala nangyari. So doon natin mag-consider yung frequency niya or yung wavelength niya is lower. Okay? Pero pagka ginamit mo na yung katulad ng sinabi dito, pag ginamit mo ng blue na transparent, makikita mo talaga doon is nagkakaroon siya ng uh, uh, nag-i-emit siya or nag-i-emit siya ng electrons. Talagang makikita mo siya dun sa experiment na yon. So, the question here, paano ba natin may a-apply itong photoelectric effects in our daily life? So ibig sabihin, ito, para lang sa akin, siguro magagamit natin to, itong photoelectric effect is when it comes to generate solar panel and also sa mga digital cameras. Bakit? Kasi because of presence of photoelectric sensors with so parang nakakapili siya what kind of different colors na kailangan different colors of light. So, usually, pagka sa photo, di ba, nagkakaroon tayo ng mga saturation. So, bakit nagkakaroon ng ganun magandang effect ng lights? So, ganun yon. So, and I hope that kahit pa paano na-explain ko po siya ng maayos. I did my best. And thank you for listening. Once again, this is Maria Elaine D. And magandang gabi po. Thank you.